Hey guys, I'm going to deliver this video about plumbing assignment. Probably break this up into two videos. Do one with the hot water and cold water sizing and then one with the drainage. So right now, from Dominique, you should have a layout. Looks something like this. So you've got cold water piping, hot water piping on there. I realize you guys don't have the full extension over here, but what I've done is I've uploaded a drawing for you guys that has all of these pipes and a hot water tank on Brightspace for you. And so anyways, it's there and you can download it and you can add it into your piping. Sizing is what it is. I find some students really struggle with it. So we'll go through this and the assignment instructions, and hopefully I'll make it clear on how it works. So there's a lot of words here, but let's try to sift through it. There's a couple things that I want because it helps me understand if you understand how sizing of piping works. You're going to do a couple tables for me in your drawing. One is with the fixture units for, this would be the sizing of the hot and cold. And the other one is the table with the drainage fixture units, right? And I've got an example that I'll show you. The other things I want is there's basically going to be three drawings you're going to pass in. There's MP1, MP2, and MP3. MP1 and MP2 are your main ones, so they're going to be your domestic cold water, hot water, and then your sanitary. We separate those two. You can do them in the same model space if you want, but we're going to separate them because there's a lot of detail that goes into plumbing drawings. And so we separate them because it makes it easier to see. MP3 is just a specs table. And from what I gather, from what you guys had already done, it may be okay. You may want to update some things. It depends. Let me just go through a brief background of what we're doing. So a method of estimating the design load for a group of plumbing fixtures is typically based on a quantity called the fixture unit, right? You call these FUs, and you hear me call them fixture units throughout this video. The fixture unit, and this is really key, is an arbitrary chosen measure that allows all types of plumbing fixtures to be expressed in common terms. That is, a fixture having twice the instantaneous flow rate of a second fixture would have a fixture unit value twice as large. The sole purpose of fixture units concept is to make it possible to calculate the design load on a system composed of different types of fixtures, each having different flow rates. Example of this is like a water closet or a toilet. It's going to have a certain amount of fixture units. A sink will have its own fixture units. It doesn't really matter about the rate of flow of the actual faucets. So the fixture units replaces basically the loading or the amount of water that the fixture produces. Similarly, we're going to talk about drain fixture units. So they're similarly, whatever goes into the sink, it's got to go down the sink. And so you're going to see that DFUs is the equivalent to fixture units in terms of the when we do the sanitary. This is discussed a little bit in the plumbing code. So we're going to use the National Plumbing Code 2015 version. You can get this in the library online, or you can search for it online as well. All right, so let's go through the process of sizing the domestic water piping. All right, so we're going to follow the small building method for sizing the water distribution system for your building. The following steps can be found in page 129 of the NBCC 2015. So that would look like this. All right, small building method. So it goes down through. All right, so this water servant's entrance, and it's up on Brightspace, so you can grab it and put it in. And so what we're going to do is size this this line here. All right, so that line is the one that basically comes from the city, the one that supplies water to your building. So sizing the water entrance. Calculate the total combined fixture units required for the entire building. See Appendix A for how to complete this step. So this is a big step. this is probably going to take you the most amount of time actually for the entire assignment. So let's go through that. So first step that you're going to want to do is check out this table. What this has, not so much this first one, but this second one. This is the fixed units for, again, this is the delivery of the water system. So on the left-hand side, this is the fixture itself. The next step here is the supply pipe. So this is telling you how big, basically the inlet size is that's going to connect to the fixture itself. Then we have these columns, right? So let's go through those. So first one's private use hydraulic load fixture unit. So private basically means that this space is only used by, say, several people. An example of this would be using this building. This washroom group that's in the back of the building would be a private washroom, right? This washroom that's out in the retail section would be a public use, right? So, and you'll see the numbers will be larger for this system as compared to this system. So we have public and private. The next is we have cold, hot, and total. So cold water basically means that if there's cold water that's being supplied to the fixture, how much is that fixture unit amount? Again, if the hot water is also being supplied, how much is that? And then is there a combined amount? So sinks or lav sinks, as they're called here, you'll see the lavatory, have hot and cold. Whereas a water closet, right, toilet, is only going to have cold water. Right? So it's going to have a cold water and a combined total. Right? And again, if it's public or private, you need to make that that number. In order to make that find that number and put it into your table. All right, so I've kind of given you an example table what it looks like. I'll take you into the drawing. I've already done this step for you to demonstrate it, so I'll show you how that's done. So here's the table. All right, so it's a table for calculating domestic cold water and domestic hot water pipe size. So on the left-hand side, fixture, I have the room number, the use, fixture quantity, hot fixture units, cold fixture units, and combined. Right, so what I've done is I've gone to each room and I've written down what fixture's there, and then obviously put the room number, and then I've labeled the use, right? And then I've gone and looked at the table and figured out hot, cold, and combined. So let's just do the kitchen sink as an example. Right, so kitchen sink. So here I've got several sink types. Right, now it's up to you what you want to choose. There isn't, I would say, that wrong of an answer. What I've done is, so that sink I've labeled it as public use, so it's going to create more water amount. It could just be a private sink if you wanted to. I just was envisioning maybe more people using it. So the sink I chose was sink commercial per faucet. So I'm just saying it's a single faucet. And so I have 3 cold, 3 hot, and 4 combined. Right? If you envision the sink not being used by that many people, you might want to choose a 1, a 1, and 1 1/4. The other thing you'll want to write down is, this goes in your specifications table on MP3, is what is the supply side. Right, so in this case, it's a 1/2 inch pipe size. Again, if you used a smaller style, we don't use 3/8 in commercial buildings. It would start at a 1/2 inch, so it would be a 1/2 inch. We could do, say, a lav sink. So a lavatory sink. These are ones that would go in the washrooms. So let's do a private lav sink. I actually have this as private. This really should be public. So let's choose a water closet, or a lav sink that's private. So we go back to the table. Here we have 3 options: lavatory 8.3 liters per minute or less, lavatory greater than 8.3 liters per minute. Sorry, there's only 2 options. So they're both 3/8. If it's private, we have a half, and 0.7. And if it was a public, we'd have 1.5, 1.5, and 2. So public washroom, I use this one, and for the private, I use this one. Right? This should be shown as 0.5. The graph, my graph here is a little bit, or my table ends up being a bit weird. Okay, so we switch that up. All right, so I go through, make my hot, cold, and combine. So once I have all my numbers together in a table, what I'm going to do is I'm going to total them up. All right, so for my combined, I got 11.1, cold, I got 9.4, and hot, I had 5. And there's no good, bad, the ugly, it just is. So once you have that done, record that, and we'll move to the next step in the assignment. So we go back to the assignment instructions. All right, so once we have our total, all right, we're going to use table A-2.6.3.12-A. All right, you don't have to go look for it. I have a copy right here below. So what we're going to do is we're going to size, again, that's our total connection piping to our building. So we're going to use 407 kPa, right? In the plumbing code, there's 3 different tables. At our campus in Fredericton, we have approximately about 59 psi water pressure, so we're going to model that. You may find in Moncton it's different, and if you really want to, you could probably go figure it out and use Moncton's if you really wanted to, but we're going to use 407 kPa. The next piece, so that helps us choose the table that we're in, all right, the pressure range. Next is use the developed length, all right, so the developed length is the distance away from the city's piping to your building entrance, right? So we don't have that on the drawing, right? So it is somewhere way over here, but we're going to assume it's 50 meters. It can be closer, all right? There's sites where it could be 10 meters away, especially if it was really close to the city roadway, but we're going to assume it's 50. All right, the next is select the length column, all right, in table A, so this table here, that is equal to or greater than the 50 meters. So in this table, you're going to see it's 12, 18, 24, 30, 46, 61. We're going to choose our allowable length based on this. So the first is we find a pressure range, right? I've given you the table, so that makes it pretty easy. The next is we're going to find this maximum allowable length. So this is our column we're going to use, all right? Our 50 meters is greater than 46, so we're going to be in this column here. All right, so in that column, find the fixed unit value that is equal to or greater than the fixed unit demand for the installation and follow the row back to the first column to locate the water pipe size. Note, we are only using the lighter gray, so that fixed unit total is 7. So in our building, we come to 61. This dark area corresponds to 1.5 meters per second. Basically, that's the maximum flow rate. The piping that we're going to be adding to our building is what's called PEX piping. It's a plastic pipe. Typically has a max velocity around 2-ish meters per second. So 2-ish meters per second puts us in this range, which is the light gray, which is this section in here. So we're only going to use this middle section. So under 61, we can't use 3. We're going to have to move down to 7. So 7 would be the first amount of fixed units that we would be able to use if that was our total. So if we go back to the table, we go down, the combined number that I have is 11.1. So 11.1, sorry, corresponds to, this would be as close as this would be close, 11, but 11 is just a little bit bigger than 11. 11.1 is just a little bit bigger than 11. So we're going to go down to 25. This number here, if we go over to the left, corresponds to, and this is the water service pipe. Our water service pipe will be 1-inch size, which is quite small for this type of building. They would likely, usually we'd either be 1.5 or 2, but for the purpose of doing this, we're just going to say it's a 1-inch pipe, right? So we start with the maximum allowable length. Once we go with maximum allowable length, we're going to only use this column for, we're only going to use this column to figure out our combined length. we're going to be in this middle gray area because that's for PEX piping. That's the velocity rate that we're going to use. And then the numbers in here are the fixture units, right? So the fixture units, again, for this is 11.1. We're just slightly greater than that. So we're going to move to 25. 25 corresponds to 1 inch pipe size. So this is where I put in my 1 inch, right? This is the pipe size that would come in. Now, I have this on a layer called MP dim. So you're going to start to see lots of my dimensions come up, and I apologize for that. But this is the first dimension that we're going to use. All right. The next what we're going to do is we're going to start to do the cold water piping. All right. So you're going to start seeing these dimensions. So hopefully you'll start to make sense of why we have those. So with the combined piping done, all right, we're going to calculate first the hot water piping size, and then we're going to do the cold water. All right. Hot water piping, because there's less of it, will have a smaller diameter piping usually in total. And then the cold water typically has more, because if you think about it, for a sink, you've got 2, cold and hot. And then for a water closet or like a toilet, you've got cold. So it would only make sense to have more cold waters than hot. All right, so calculate all the hot water fixture units. So we've already done that. All right, I've showed you how to do that for the fixture units. You should have a table of that in your model space. This is the next piece. So measure the distance from the hot water tank to the furthest hot water fixture. So this is the developed length, all right? We assumed it was 50 meters in the first one. In this one, we need to measure it in our building, right? Now, this is going to vary from group to group, depending on where your things are, right? So if you've got things in different places, you may find that groups have different numbers here, okay? So measure the actual pipe length, all right? So I'll show you how to do this. Do not take the direct route, all right? Don't just measure on an angle. Follow the pipe, measure the whole thing. And you're also going to include 3 meters for any vertical drops, right? That's going to be included in the distance itself. So this distance is your developed length for sizing hot water piping. And this distance is going to be different than your commercial building piping, which is okay. Okay, so what we're going to do is we're going to start and measure our furthest distance. Now, you're going to need to do this for cold water as well and hot water. So what I've done is you can either start your hot water tank or to get your developed length for your hot water, or what most people do is they start from the service entrance, right, when it comes into your building, and they measure the longest distance that is to your furthest fixture, which I've done. Right, so I know in the instructions says measure from your hot water line. It doesn't really matter hot or cold unless you have like a really far away toilet or something, or some sink that only has cold water or hot water that's furthest away. So anyways, I start at the service entrance, all right, from the wall. And then I measure the distance basically along a stretch of pipe. So here I've taken it from the hot water tank. I could have just as easily gone here and around. This dimension here is this length here, okay? And then what I've said is this fixture here, which is a sink, is probably my furthest distance away, right? So when I say measure along the pipeline, what I mean is start here, measure, and go all the way along, right? And then the last bit is measuring to where the pipe connection is. And you can measure right to the fixture. Now, this is somewhat approximate, all right? So even in this measurement, when I got this ready, this dimension here could have been a little bit less, could have just went to here. The next step is you're going to add all these up, right? You're going to add up every single distance, all right, and get a total. And so I think I've done that somewhere. Okay, I've added this in, so it was on another layer, unfortunately. So here I've maximum allowable length, so I add them all up, right? And then what I said is basically for this, so it comes in the building, and then it's going to go up here. I've added 3 feet times 2, so it's gone up 3 feet from here and 3 feet down, right? Now, it could be a little bit more depending, or a little bit less. Again, it's a bit approximate. So when I do that math, it comes out to about 79 feet. The big one for us for me, marking your stuff is just don't take a straight line. All right. Take into account these bends. It adds a little bit. You can always round a little bit up if you need to. All right. So I got 79 feet as my developed length. All right. So go back to the assignment instructions. So start by sizing the most remote outlet. In the most distant fixture requires hot water. This process is similar to the combined piping, except the development length has changed. So what we need to do is we need to use this table, right, to size our piping. Okay, so the distance I had was 24 meters. So 24 meters is this column here, right? Now, what I can do is I can put 6 fixture units on a 1/2 inch line. And just so you're aware, this is the service pipe. We're now in the distribution. So we're inside the building. So 24 is our number. 6 is our starting number. So what we're going to do is we're going to start at the furthest fixture away and start moving our way back. So when I look at this sink, again, it has 3 hot water fixture units. Right, so I have my 3. Now this pipe size, right, what we always want to check is that it's 2 things you want to check. One is you want to check this table. So with 3 fixture units, I'm less than 6, right, which is good. That means that the pipe size is a 1/2 inch. Now I always want to check this and make sure that is my pipe size a 1/2 inch or 1/2 inch, really. And if you remember for a sink, it is in my table over here. My sink in that kitchen sink here has a 1/2 inch cold water and domestic hot water line, right? So it is a 1/2 inch line. So I am good. And let's turn on my, right? So I put the 1/2 inch line over there. So this is a 1/2 inch line. Now I'm going to come all the way over here. What I'm looking for is when I meet a T, a junction, right? I'm going to place my fixture unit total next to the junction. So I put it here, and I put it on a layer called fixture units, and I would encourage you to do the same, right? So you can do fixture unit hot, fixture water cold, whatever, or just have fixture units, right? And put it on a layer. And what I'm going to do is I'm going to move to my next location, which is down here. So in here, I've got a water closet, which is only going to have cold water. Here, I have a sink. I'm just going to turn these off for now. All right, this is a lab sink, public. So it's got a 1.5 for each side, right? Hot water. So 1.5 is going to come up. Sorry, before that, we have 1.5. All right, we go to use our table. 1.5 is less than 6, which means it's going to be a 1/2 inch line. And just do a quick check. That is a P2. So lavatory has a 1/2 inch line. Right? You always have to do that kind of circle check to make sure that the actual fixture doesn't have a bigger size of pipe than it's required. You'll see that sometimes with the water closets, for example, it can be much larger. So we have to move up the amount of fixture units regardless. If the fixture's size piping is bigger than what the fixture units is saying, we have to size up. You can't size smaller. All right, so we have 1.5, and this is a 1/2 inch line. And so what we have is we have 1.5 meeting a 3. Okay, so a 3 and 1.5. This size right here would be 4.5. I think this might have been for cold water. I'm going to change this, 4.5. Okay, so this is a 4.5. So we have 1.5, 3, and 4.5. So this pipe here is a 1/2 inch. This pipe here is a 1/2 inch. This pipe here, 4.5. Again, we go back to our table, is less than 6. It will be a 1/2 inch as well. And one of the key things, gang, is that when you go down to your table, my total hot water fixtures end up being 5. So 5 is less than 6. So basically all my hot water piping is 1/2 inch regardless. The only thing I'd have to make sure is that any of my fixtures from my table, if any of them were greater than 1/2 inch, I'd have to change it, but they're all 1/2 inch. So basically the size of this hot water pipe from start to finish right to my tank is 1/2 inch. Right, so I basically have a 1/2 inch goes all the way back into my tank, and a 1/2 inch comes from my cold water line to my hot water tank. So I'm just going to turn my fixture units off for a second, and the non-print layer. It's going to be confusing. So labeling, all right? What you're going to want to label is basically there's a pipe coming in here to your hot water tank. We want to label that. Frequency of labeling, all right? Basically, anytime my pipe is going to meet a junction, I need to label it. So this would be a good example. So this is going to be a 1/2 inch. You're going to see here, this is a 1/2 inch. I should label it right here or near here because I have a 1/2 inch that's changing or could change, except it is a 1/2 inch. And it's also moving to this one, which is a 1/2 inch. Okay. So that's the frequency of labeling. You'll see designers sometimes put very little dimensions and sometimes they overdimension. There isn't really a standard. The way we like it here is that whenever you meet a T junction, you're telling me there's a 1/2 inch, and then somewhere along here, you're going to give me another one. All right, similar to here. We have a T junction, I have a 1/2, a 1/2, and a 1/2. All right, I know what it is. Okay, that's hot water. Now, yours could have been larger than 5 fixture units for hot water. Like cold water example, I will exceed 5, right? So I'll go through that and hopefully show you what happens when you exceed 5. So the cold water is the exact same procedure as the hot water, right? Let me go back to the assignment instructions. So for cold water, repeat steps 1 to 4 of the hot water piping, but use the cold water piping sizing tables. All right, so let me put on my non-print layer. Okay, so for cold water, I've got 9.4. So I'm going to go over 6, right? So I'll show you what happens when you go over 6. So again, you start at the most furthest location away, right? It would be this one again. So this, for fixture units, let me turn all that off. I must have deleted that. Weird. Okay. So again, I'm going to have 3 fixture units on my cold. So I'm going to paste that twice. So there's 3 hot, 3 cold. All right. 3 fixture units. Okay. So we're going to go, again, circle. You go here. It's the hot water, cold water system, again, is the same. And even if you had one fixture, which was the cold water that was the furthest away, you can still use this table for that developed length if you wanted to. All right. So once you have your developed length, you can stick to it throughout the whole calculation. So here we're going to use this one. So 24, 6, 1/2 inch. All right. So again, the circle that you want to check, make sure that this fixture is a 1/2 inch. So this is the kitchen sink, 1/2 inch. So just I'm going to take a quick look. All of these are 1/2 inch. So if I have a 1/2 inch as my starting, which is great. So again, this cold water line is a 1/2 inch. It's going to come all the way out here. Again, I have 3 fixture units right here at the T, and we go down here, right? So this next fixture is a water closet, all right? Water closet. Come down to our table. It has a cold fixture total of 2.2. Or sorry, this is our public. Yeah, 2.2. Right? It has a 1/2 inch line as well. Now we have a T junction here. All right. This one is a public lab sink. So this is room 3. So it has a 1.5 cold. So we have 2.2, 1.5, 3.7, right? This is a 1/2 inch. half inch coming up. We need to check what this connection is. 3.7. Hopefully you guys get this now. 3.7 is less than 6. This line here would be half inch. Okay, and if I turn this on, we have a half inch line, and if I climb up here, I have a half inch line. Right, so let's turn dimensions off for a second. So we have a 3 meeting, this was our 4.5, or sorry, 3.7. So I'll copy this up. So we have 3, 3.7. So 3.7 on this one, 3 on this pipe. That means this is a 6.7. Right? 3 plus 3.7. So let's copy this. I'll just move it down the line. So again, that's this branch. So 6.7. So this is our first one where we need to size up. All right, we are greater than 6. So here's what happens. Right, see this? 6. So we move to the right. This is 5, so we're greater than that, so we have to move down. Here we're at 11. Now, we could use 5/8, except I have a note here, right, which is probably buried, which is right here. All right, you do not use 5/8 piping. All right, this is not used in commercial. You're allowed to use it in the codes for both residential and commercial. 5/8 is not used. You want to use the next greatest size. So the next greatest size, we come down here is 3/4 inch. We come over here. Now we can go up to 14 fixture units. Okay. So we have 3/4 inch line, 14. Right. So we can't use 5/8. So when you strike out this, we have to go down 1. So we're right here. So 3/4 inch would be the size of this line. Okay, and I'll turn that on. Right, so we have a 3/4 inch line, which is right there behind my fixture units. Okay. Now we have another juncture, which is this one. Okay, so we have a 3/4 inch line. Now, something to note. In my table, I have a total of 11.1. Right, that is less than 14, which means that the line basically back to this connection, this junction between cold water and the hot water will be 3/4 inch. Okay, so this length here, and then this one we just determined will be 3/4. All we need to do is size this last junction. So without fixture units, you guys can probably see that we have a sink in a water closet. The sink is a 1/2 inch. The water closet is a 1/2 inch. The total is the same as this one. Right, so we had, I guess it's a little bit less because it's a private lav sink. But so lav sink is going to have basically 0.5 and 2.2. So it's 2.7. 2.7, we go back to our table here, is less than 6. Right, so we go back to our original section to size each branch, is less than 6, which means it'll be a 1/2 inch line all the way up. Right. I don't expect you to get this all at once. If you have questions, please ask. But that's how you size hot and cold water. Right? And again, the thing that I'm asking for you guys to do is, you place them wherever you're going to have basically a change in the length of the pipe. Place them. This one for the hot water, I did run a 1/2 inch and a 1/2 inch to make it clear on what you guys have, but you would only need one section along this pipe. Let me just go over a couple notes here that I have just before I forget. So this is double check valve, water valve is required by code, see CAD file and Brightspace, already talked about that. Limit of plumbing contract. So this note is to ensure your work is not responsible beyond this point. This is a common one to basically say, after this point, it's on another contractor to pick up the work, or a designer to ensure the work is done correctly. All right, so that's why we have the text there. What else? Some of these other ones are for the drainage. Yeah, so there's all sanitary ones. Okay, I think we're good. All right, for that video, I hope you've understood how to do hot and cold. I will move on to doing the sanitary next on a new video.